Alright guys, before we get into the video, I have two things to show you. The first thing is the game, obviously. So, this is a stealth game, and basically we follow a series of points. This is the enemy here, and the enemy will run along these points until it gets to the last one, and then it will loop back to the start, and it will just run that same route to patrol, essentially. Now, the patrol path that I've made is very boring, right? It just runs around here, and then it runs back. Very simple. And if I hit play, we can see our character, and I'm gonna hide from him so he can't catch me. But now I'll let him catch me. As you can see, it says you've been caught, and he walks up to us. And that's it. Obviously, in a real scenario, you would do a lot more than just say you've been caught, but this is basically just AI and sensing and stuff like that. The second thing I just want to really quickly cover is I am now doing private tutoring. So, you know, I'm not a pro, but I do have a good skill set in the Unreal Engine, and if you really want to head start your skills with C++ in the Unreal Engine, or there's a specific thing you really want to know, then send me a message and we'll discuss it. You know, this is for the people that want a little bit more than just my free videos and they've enjoyed my content. So, anyways, enjoy the video. Hey, what's up? So, in this one, we're going to be doing a stealth game. We're going to be creating a basic AI and looking at behavior trees and the blackboard. Before I start this, I just want to say thank you to allfeasible.com, and I will link that in the description. That guy has some really good tutorials, and this tutorial is in part sort of based off one of his tutorials. It does take some stuff from one of his tutorials, so I will link that in the description. Go check him out. He has some really good stuff, and he is actually very underrated. Yeah, really good stuff over there if you're looking to learn C++. So, without further ado, let's get started. So, the first thing to do is to explain a little bit about what we're actually going to be doing. To make an AI, you need to use a AI character, which is just going to be a copy of the normal character class. We will need a controller, which will inherit from the AI controller class. So if you don't know what a controller is, basically you have a character, and then you actually have a controller. And the controller is basically, you know, the person controlling the pawn or whatever. So they are separate entities. The controller is what possesses this pawn and makes the pawn move around and do things. So we're going to make an AI controller to take control of that AI and walk it around and stuff like that. And then we're going to have a target point. And we can drag and drop these on, and the bot is going to know where to walk around using these target points. So we're going to create like a a patrol system where it just walks around in sort of the same general loop. Alright, let's get started. So we'll go to our C++ classes and come into here and right click on the character, and we'll go, oh actually sorry, we're not going to be doing anything from stealth character. We'll right click new C++ class character next, and I'm going to call this one patrol AI. In fact, AI patrol, because I want them to all start with AI. So we'll create that. Alright, the next one we need to create is the AI controller. So we'll go new C++ class again. We'll go to show all classes and type in AI controller. And this is the class that we use to control our AI. So let's go next. And we'll call this AI patrol controller. Alright, and the last class that we need is our target point. So go new C++ class and show all classes and type in target point and then make one based off target point. I'm just going to call this patrol point, AI patrol point. So we've created that class now. And And what we're going to do is we're going to take these classes that we make and extend them using blueprints, which is just going to make things a little bit easier and more clean. So in the content browser here, I'm going to add a new folder, and I'm going to call it AI. Inside of AI, I'm going to make two new folders. One of them is going to be called Blackboard, and the other one, in fact, we'll call that Behavior. And the other folder is going to be called Blueprint Extensions. There we go. So I'm going to right click on AI Patrol and create a blueprint class and put it into Blueprint Extensions. And I'm going to call this BP_AI Control. Alright, so we made that. Close that. And we will also extend our patrol point. And we will finally extend our controller. So right click on that, create blueprint class, and we're going to call this BP_AI Patrol Controller. Okay, so we'll save all of those and close them. Now inside of our AI folder, you will have noticed I've made this behavior one. Inside of this, we're going to add an artificial intelligence behavior tree, and I'm going to call this Patrol AI, or AI Patrol BT. And we'll make a blackboard, and this is called AI Patrol BB. And so the behavior tree is always linked up to a blackboard. The blackboard is kind of where you store variables that the behavior tree will use, if that makes sense. And I will explain what a behavior tree and a blackboard is more in depth when we actually go to use them. Okay, so let's go write some code. The first thing we're going to do is come into our controller, our character. And I'm going to remove the tick function because we're not going to need it. So just close that, get rid of that, and get rid of this line here that says can tick. And in the header, we're going to add this line here, uProperty, edit anywhere. And we're going to give it a category, which I'm just going to give it AI. And then we're going to use a type called uBehaviorTree. Behavior tree. So we have our behavior tree linked up to the header. We'll just go ahead and compile now. And when we've compiled, we can link it up to our character. So this behavior tree that we've just made, we can actually link it up now. And really quick, I'm just going to open up the behavior tree. And as you can see, for the Blackboard asset, just make sure you have Patrol BB selected. I believe it should already be selected anyway, but just make sure it is. So the next thing to do is to open up the character. And if we go into the full blueprint editor, there is this option up here, behavior tree, that we've just added. And you want to go down and select your behavior tree that we made. So the behavior tree is now added. We'll click on this little viewport tab, and let's set up this AI. So in this case, I just want the AI to use the mannequin. So we'll click on Mesh and select the mannequin skeletal mesh. And we'll rotate it so that it's facing the blue arrow. And then we'll move it into place. There we go. So that's set up. The last thing to do is to select the animation that we want it to use. So if we go to animation class and select third person anim BP, our enemy, or our guard or patrol or whatever, is now animated and it's ready to be dropped into the level. So we'll go ahead and save that and then compile it. And that's going to crash the Unreal Engine because, who knows, but whatever, go send and restart. That happens pretty often. If it crashed for you, that's alright, just reopen it, repeat the process and it won't crash the next time. I don't know why that happens, it's really stupid, but anyhow, we'll open up stealth again. And this time, when we go to compile, it will do so successfully for some reason. No idea why. So click restore now. And then open the full blueprint editor. And now just save. And yeah, it should be good to go. If we go to the viewport, save, compile, whatever, I think we're now good. So the next thing to do is to set up the AI controller. So like I said, the AI controller is basically just something that takes control of the pawn and kind of dictates its behavior. So to access this, we're just going to go into our A patrol controller header, and we're going to start adding some code. So the first thing we need is the constructor. So AI patrol controller. So that's added now, and then we need two inline getter functions. So I'm just going to write a comment here. Inline getter functions. So this is going to get the blackboard component, and I haven't actually defined that yet. So we'll come up here, and we will say our behavior tree. Oh, sorry. Our blackboard component. So here we'll just say you blackboard component. Blackboard comp. So there we go. We now have a blackboard component, and we have a getter function for our blackboard component. So that's good. That's the first step. The next thing we need to do is add a behavior tree component. So let's add that as well. Behavior tree component. You behavior tree component. Behavior comp. There we go. So we now have a reference to our behavior tree and to our blackboard. Awesome. So the blackboard uses what are called keys, and these keys basically in code we point to the blackboard keys. They might not make sense right now, but once we implement it, you'll see what I mean. So I'm going to say blackboard keys. I'm going to make it say U property edit anywhere. Actually, it is edit defaults only. Category equals AI. And the keys use a system called fnames. And that is essentially just an f string, but it's just used when we want to give a name to something. And fnames don't generally allow for stuff like string manipulation and that sort of stuff. Okay, so we will define the location to go key. This is the location that the bot needs to walk to. And then there's another one. And the other one is a reference to the player, where the player is, so we know to run at the player. So player key, we'll call it. Okay, so there are a few more things we need to do, a few more steps. The next thing we're going to do is define a T-array of actors. And I'll explain why we use actors and not target points, but what this does is it stores all the patrol points, and it lets us, we basically get all the actors and store them in that target points array, and then we find the next target point to walk to. So I'll add that in. T-array actor, and we'll say patrol points. So this array stores all of the patrol points which we will add, and they're quite easy to add as well. The next thing we need to do is override the possess function, so virtual void possess override, and so that's overrided now, and that is the function that's called when we when we possess our pawn. And it also takes a parameter which is a pawn, obviously. And there we go. So that's basically the header file. The last thing we need to do is just to make a force inline getter for our behavior tree. So, actually no, it's for our target points, isn't it? So, TArray of actor pointers, get patrol points, there we go. So those are our force inline functions, and that's pretty much it, I believe. So let's go into our CPP, and we'll actually start putting some functionality into this. So in the CPP, I'm going to use Visual Studio's option to implement all of these. Okay, so we have our possess and our constructor implemented. Let's go into our CPP now and start writing some code. So I'm going to add a bunch of includes. There's actually an absolute ton. So feel free to just skip ahead. In fact, I'm going to pause and I'll just start the video when I've added all the includes, and you guys can copy those in. Okay, so I've added all of these header files. These are all the ones that you're going to need. So go ahead, pause the video, add those in if you need. And let's get started. The first thing we need to do is initialize our blackboard and our behavior tree. So initialize blackboard and behavior tree. We're going to say behavior tree component equals create default subobject new behavior tree component. And then we'll initialize the blackboard as well. Okay, and that is the blackboard and behavior comp done. What I'm going to do is I'm going to add another key, because there's one more key. Oh, actually no, we have it. Okay, so in my constructor, I'm going to initialize these keys. So initialize blackboard keys. So we're going to say that location to go key equals location to go. So that's the name of the key inside the blackboard. And then also player key equals, and we'll just call this target. So the target that the AI is chasing, essentially. The next thing I'm going to do is add the possess code. First thing we need to do is call the super function possess and pass in pawn. So we'll type in get reference to the character. We're going to say AI patrol AI character equals cast AI patrol and pass the pawn in. So now we have a reference to the AI. We need to check if the cast was actually successful, so we're going to say AI character, and now inside of these little spike brackets, anything in here is safe. We know that the cast was successful. So let's first of all check if the blackboard is not null. So to do that, we're going to say AI character, behavior tree, blackboard asset. So if that's not null, then we can initialize it. So blackboard comp, initialize blackboard, and this requires the pointer. So AI character, behavior tree, blackboard asset. And now we've initialized the blackboard. The last thing to do is to populate the patrol points array with all the patrol points that we've laid out in the game. Now obviously we haven't laid those out yet, but we will be doing so. So we're going to say populate patrol point array. And to do that, very easy, all we need to do is gameplay statics, get all actors of class, get world, AI patrol point, static class, and then finally the patrol point array that we want to store all of our patrol points inside of. Okay, so we got that, and now we're just going to start the tree. So we've initialized the blackboard, now we just start the tree. So to do that, we call the start tree function, and this takes the AI character behavior tree. And there we go. So that was basically all we need for the possess function. So with that in mind, one more thing I'm going to add is the set player caught function. And this is the function that is called when we actually catch the player. So when we find the player, when the AI catches the player or notices the player or sees him, then this function is called. So set player caught. And it will take a pawn. Now this is a pretty basic function. All it does is check if the blackboard is not null. So say if blackboard comp set value as object, and this is going to set the value of our key. And so this takes two arguments, the key, so we'll pass in player key, and then finally we pass in the pawn. Alright, and that is the set player caught function fully done. The last thing that I'm going to do is add a int32 current patrol point. And this is the variable that I'm using to track what patrol point we're at. And we'll use this to loop back around back to the start. And you'll see when I do it what will happen. Current patrol point equals 0. And there we go. Now, I believe that is it. So, I'll start recording at the next part. Alright, next up we're going to be implementing a very cool little component, and it is known as a pawn sensing component. And it is basically the sensors for the bot, or the AI. So when the AI walks around, using a pawn sensing component, we can essentially give the pawn vision. And allow it to catch the character, if you will. So we're going to go back to the AI patrol. Not done with that quite yet. And we're going to add the pawn sensing component. So U property, visible anywhere, category equals AI. Class, U pawn sensing component, pawn sensing comp. Finally, I'm just going to add a private function called onPlayerCaught. We'll go ahead and create a definition of that. And this one is a pretty basic little function. And all we do is we get a reference to the player controller, so AI patrol controller, and we cannot use that yet because we've got to add a reference to it in the header file. So to do that, we're going to include some more of these includes. I'm not going to stop recording because basically got most of them. AI patrol controller.h. Include behavior tree / behavior tree.h. And then finally, the perception / pawn sensing component. And that lets us do the sensing. Inside of the constructor, I'm just going to initialize the pawn sensors. So initialize sensors. And so we're going to say pawn sensing component equals create default subobject pawn sensing component and then we're going to set the peripheral vision of our AI. So to do that, we're going to call this function set peripheral vision angle, and I'm going to set the vision to 90 degrees. In the begin play function, I'm going to add a dynamic to the pawn sensors. So we're going to check if the pawn sensors are initialized, and then if they are, we're going to say pawn sensing component on C pawn dot add dynamic. Inside of that, we're going to put this and then a reference to our characters on player court function. So AI patrol on player court. And there we go. So what we're saying here is if the AI catches the player, then we can go ahead and call the on player court function. The last thing I'm going to do is write the on player court function. So we're going to start by saying get a reference to the player controller. And we need to pass in get controller to get that. So just get controller. And because this is the pawn, it knows to get the controller currently assigned to it. Now all I'm going to do here is just say if AI controller. So at this point we know we've been caught. So we'll say AI controller set player caught pawn. And I'm also going to make it just send a message to the screen. So we'll go to stealth.h, change engine minimal to engine.h, save and close that, and then we'll go back and just type in gengine, add on-screen debug message. And we'll just add a message to the screen. You have been caught. So that is in the case that the player is caught by the pawn. And I want to say that that's pretty much it. And now we can actually start with our behavior tree, which is one of the more exciting parts of the tutorial. So we'll go back to AI, go to our blueprint extensions, and in the controller, I don't think there's anything to set here. Let's just compile really quick, because we did write some code, so we need to make sure that's all compiled. While we're waiting for it to compile, we'll go to behavior and open up our blackboard. We can delete this self-actor one, we don't really need that. I'm going to add a new key, so just type in new key of type object, and we're going to call this location to go. And in location to go, that's pretty much good. Because we've set the key up as location to go, it will find this. The next one to add, I believe we called it target, so we'll go add, and then add target. And there we go, we'll save that. And we now have the target. Right. The last thing we need to do before we can start working with our behavior tree is to create a custom task for our behavior tree. The reason we need to make a custom task is because the task we want to use isn't natively supported. So let's make a new task. To do that, we're going to go to classes and make a new C++ class, and we're going to base it off the BT task node. Go next. And I'm going to call this select. Actually, we'll go BT select patrol point. We'll go create class. And this is the last class we need to deal with before we can tie it all together in our behavior tree. And then we should have working AI. So we'll go ahead and write this class out. Okay. We'll add a couple of headers here, so AI patrol point.h. AI patrol controller.h. And the last one we need is include behavior tree / backboard component.h. Alright, that's the last thing we need. Let's go into the header file here, and we will write this up. So, in the header, we need one function, which will be an overrided function, virtual EBT node result type, and this is, I'm not going to explain what type is yet. You'll actually see when we return a type, you'll see what that does. It's kind of the same as returning true or false, but there are some other types we can return as well. So don't worry too much about the parameters and stuff, but we're going to go ahead and implement this function. And this function is going to execute a task that we will define ourselves. And this is probably one of the most interesting parts, where we make our own behavior tree task. You'll see how this works, and yeah, relatively interesting. Seems like I've done something wrong here. What have I done wrong? I want to say I didn't do anything wrong there. No, I think I've done this okay. Let's just... Yeah, we did do it fine. There we go. There we go. Alright, so, let's write this function. We'll go to the C++ file. So inside of execute task, first thing we need to do is get a reference to the patrol controller. And I'm going to call this AI con, and we'll cast this and we'll say owner comp dot get AI owner. So this gets the AI that we're working with. The next thing to do is to check if the cast was successful. So AI con, and we will get the blackboard component associated with our possess pawn controller. So get bb component. So we're going to say u blackboard component, blackboard comp equals AICon get blackboard component. Now we need to declare an AI patrol point. So to do that, AI patrol point current point equals cast blackboard comp get value as object location to go. Now we need to get all the available patrol points. So to do that, I'm going to make a T array full of actors, and we're going to call this array available patrol points. Equals AICon get patrol points. Okay, so we have all of our patrol points. We're going to declare a variable to store the next point that we want to go to. So we're going to make an AI patrol point, and we'll call this next patrol point. And we're just going to set that to null for now. Okay. The next thing to do is to check if there are any more points to go to. So let's assume that there are 5 points that our AI can walk to. Well, if it's at the last point, there are no more points to go to. So we need to tell the AI to go back to the start. So to do this, we're going to say if AICon current patrol point yeah, it's there. Oh, we haven't made that public, so we're going to copy that and put that in the public section, and now we can access it. So if the current patrol point is not equal to available patrol points .num -1, then we can just send it to the next patrol point. So that means, okay, it's not equal to the end of the array, so there must be some more patrol points we can go to. So just increment current patrol point and move on to the next one. So, so available patrol points at the index of ++AICon current patrol point. So add 1 to the current patrol point and search at that index, basically. Now else is if there is not any more points to go to. So else if there is not any more points to go to, then just go back to the start. So next patrol point equals cast into AI patrol point. And we're just going to say available patrol points 0. So just go back to the first one, and then reset AICon back to being 0. Let's update the blackboard component's next location to walk to. We'll say set value as object. Location to go. So we're telling the blackboard where the next point is. And at this point we have succeeded. So what we're going to do is return EBT node result succeeded. And that is what that type thing is. If we couldn't do that, we will return EBT node result failed. Alright, and that is the select patrol point custom task. So we've made our own custom task, and that's basically all ready to go. Once this compiles, we'll be able to drag everything in, and we should have a working stealth game. While I'm waiting for this to compile, I'm just going to move a couple of these cubes around just so we can use them to hide from our enemy. Alright. So let's take our AI patrol character. So our patrol character is now in the level, although for some reason the mesh hasn't been assigned. So let's put the mesh on there. And again, for some reason it's... Oh, whoops. Yeah, we don't want this one. We want the blueprint that we extended. So we'll go to AI, blueprint extensions, and drag that one in. So this character is all ready to roll, basically. As you can see, this is the pawn sensing component, this huge big circle we can see here. And you can set this up if you want. So if we go to pawn sensing comp, I'm going to change this down to about 2000. So you can now see that the sensing component is a little bit smaller. So the pawn can't see crazy far. Now what we're going to do is drag in the patrol points. So this is the path that we want our AI to follow. Let's drag some of these in. We'll go here, 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 here. Make sure they're fairly close together. And that's a good path for me to walk through there. You could add more if you want, but I want to keep it nice and short, so let's go ahead and go to our behavior tree and we'll get this all set up. To set up a behavior tree, the first thing we're going to do is make a sequence. How a sequence works is everything is executed left to right. So what I'm going to do is we'll drag off a wait as well. So that is our wait. The next thing is to drag out a... If we go to tasks, our custom class is going to be there. And then we're going to drag out a move to. And it's going to move to the location to go. So what it's going to do here is it executes left to right. So it starts here, then goes here, then goes here, and then repeats. As you can see, it's going to start here and it's going to find us a patrol point. Then it's going to move to the location which we've set inside of our code. Then it's going to wait 5 seconds. What we also want it to do though is check for our player. So to check for our player, what we're going to do is drag out a move to. And we're going to say, move to the target if we can. Now there's a wee bug where if you try to select the key, it doesn't appear. Not really sure why that happens, but to fix that, we're going to go to the blackboard. And we're going to remove location to go. Go back to the tree. I know this is a little bit ridiculous. We're going to say move to target. Right click, add decorator, blackboard. And so here it's saying if target is set. So if the target variable is set, it's going to move to the target. I'm going to add back in that variable that we took out. I'm not sure why it does that. Quite frustrating. We'll add back a new key. Location to go. And say move to. And it wants to select target, and I'm really not sure why it wants to select target. Very weird. Let's delete target briefly. This is a weird bug. At least I'm fairly sure it's a bug, so... Okay, so we're going to drag this out. Now that target's deleted, it's okay if it says invalid here. We're going to select move to, and it's going to move to the location to go. Now I'm going to go back to my blackboard and add target in again. I know that's annoying, but for some reason it just doesn't want to show up. So I'm going to type in target here, and now it should be ready to go. So what it's going to do is it's going to say, find a patrol point, move to the patrol point. If we see the player, walk towards the player. And at each patrol point, I'll make it that we wait for, say, 1 second. I don't really want to wait that long. And we're also going to right-click, add decorator, blackboard, and click on this where it says location to go is set, and change that to is not set. And under location to go, change that to target. So I should say, if target is not set, move to location to go. What I'm saying here is, find a patrol point. If we have not seen the player, then go to the patrol point. If we have seen the player though, what we're going to do is move to the player. And that's it. So we'll save that. And I believe that's pretty much all we need. Let's hit play. And we'll see if it bumps any action. And right now it does not seem to be moving. I didn't save the tree, that might have been the problem. No, I'll start recording when I find the problem. Shouldn't be a very hard fix, so I'll be back in a sec. Okay guys, so the problem was quite simple. All I needed to do was go into my controller and select it to use my controller, and because by default it uses AI controller, we want to use the BP AI Patrol controller that we actually made ourselves. The last thing we need is a nav mesh bounds. And this is basically, it just tells the AI where it can walk. So drag that into your level, and we're just going to pull this out to basically just engulf the whole map. And if you press P on your keyboard, you should get a highlight of where the pawn can walk. So we're going to press P again to hide that. And now if we go into the game, we've been caught. So it's now running and it's found us. But if we hide from it, which might be harder than I think. Yeah, and it just runs back to the start because it gets here and then it runs out of points and it goes to run back to the start. So you can see how you can make some pretty amusing games where you have to hide from enemies and stuff like that. Obviously, this example isn't the best game in the world, but it does serve as a very basic sort of example of this sort of game. And as you can see, yeah, you could probably make a pretty fun game where, you have to hide from pawns and stuff, but this is the first video I've done on stealth type stuff, so if you did like it, let me know, and I might do some more stealth game type things, but anyways guys, I'll see you in the next video.